So our last bit for chapter 5, we're actually skipping around a little bit. So we're going to go to 5.5, which is just solving rational equations. So we're going to still use that idea of your LCM. It's just we're going to use it a little differently here. So not through sections 1.1 and 1.4, we just did 1.1, 1.2, but we studied operations with rational expressions. These operations do not have equal signs. A rational equation is an equation containing one or more rational expressions. So here we're going to have rational expressions and they're going to be equal to something. So we have 2x minus 7 over 4 plus x plus 5 over x equals 8. That's a rational equation because we have rational expressions. Same thing here, rational expression, rational expression, rational expression. So maybe both sides will be these rational expressions like this that are going to be fractions involved. X plus 5 over x plus 4 is a rational expression. And you can actually even argue that x squared plus 2x equals 5 would also be a rational expression because all of those could be divided over 1, and that could also be considered a rational expression. But we're going to focus on ones where we actually have x in the denominator as a little bit more of the ones that we're concerned with. So to solve rational expressions, recall that one way to clear fractions from an equation, we did this quite a while ago towards the beginning of class when we were talking about linear equations, is to multiply both sides of the equation by your LCM. So to solve a rational equation, the first step is to clear the equation of fractions. To do this, we multiply all terms on both sides of the equation by the LCM of all the denominators. So we're going to find that LCM again, but instead of trying to give everything the same denominator, we're going to multiply everything by that LCM. So remember, all your denominators should divide into that LCM. So that's what we saw when we were looking at 5.2. So from there, we're going to carry out the equation solving process like we did with any kind of linear equation. There's just one thing we have to watch out for here is that we're going to get what we call extraneous solutions. Okay. So if I have 2x minus 7 over 4x plus x plus 5 over x equals 8, we need the LCD, or the least common multiple of your denominators. In that case, would just be 4x. Because this, we got a 4, we have an x. Those are the only two factors that we have. So what we're going to do is we're going to take a rational equation. Let me write that again because that was getting a little too big. I'm going to take it. And what we're going to do is we're going to multiply both sides. Because remember, it's an equation, so what do I do to one side, I have to do the other. But I'm going to multiply by that LCM. So if I distribute this through, I'm going to have 4x times 2x minus 7 over 4x. If I distribute here, then I'm going to have 4x times x plus 5. That's always going to go to the top. You just think of it as a fraction over 1 is what we're multiplying by. And then here, we're just going to have 32x. So what we're going to do is we can see through simplifying, 4's go, x's go, that all I'm going to be left with is just that is the wrong color, the 2x minus 7. And then here we see that we just lose the x, but we keep the 4. So what we have here is just going to be plus. We have the 4, and then we just have the x plus 5. So I just made sure I simplified basically all of my factual parts with a denominator. I simplified all those. And now what we have here is just a linear equation. So this is just 2x minus 7 plus 4x plus 20 equals 32x, which is then just going to be 6x plus 13 over 32x, which is still going to be, let's move the 6 over x over, so it's going to be 13 over, let me see, so we're going to 2, so 26x, and if I divide by x, then I'm just going to have 13 over 26. So we see that x is just going to be 1/2. And one of the things we're definitely going to want to do in this section is we're definitely going to want to check our solutions. I'm going to talk about a little bit more why in a second. But if we go back and I have 2 times 1/2 minus 7 over 4 times 1/2 plus 1/2 plus 5 divided by 1/2 equals 8. We're going to see if this stays true. So we're going to end up with 1 minus 7 over 2. And then here we're going to end up with 5, 10, 11 over 2 divided by 1/2 equals 8. So we're going to end up with negative 6 over 3. This is just going to turn into 11. So we get negative 2 plus 11 equals 8. And, oh, no, negative 2. This would be 3. So negative 3 plus 11 equals 8. So we end up with 8 equals 8. So this is definitely my solution. Okay. So you remember that part I told you that when we simplify a rational expression that we get something that is equivalent most of the time. It's just there's a few places that's not equivalent. One of the things that causes is that we have to check our solutions because it's quite possible that our solution is actually something that cannot be a solution. It's not something that's in our domain. And that has to do with the idea of like I said, when we simplify, we actually change the domain of our rational expressions sometimes. And what that causes is that we say solutions could be there that really can't be there. Also, because we're multiplying by that LCM, that also makes a little change to our equation as well. So this happens a lot when we're trying to solve equations, is that we're rewriting the expression in a way that's not completely equivalent. And that is what's happening here by multiplying by this LCM, is we may get something that is not actually equivalent. So when we multiply all terms of both sides in the equation by the LCM, the resulting equation might yield numbers that are not solutions to the original equations. Thus, we must always check our solutions and see if they're actually going to be solutions. Like I said, what we get is that solutions that are not solutions, or we have extra solutions. That are not really solutions. Those are called extraneous solutions. And these happen quite a bit. Like I said, there's a lot of, outside of linear equations, a lot of polynomials, a lot of other equations we deal with, the ways that we get around getting them to something that we can solve, which is making them look like polynomials or rationals, usually results in us getting something that's not exactly equivalent. And that's how we get those extraneous solutions. If you carry out all the algebraic procedures correctly, you need to only check to see whether the number makes a denominator of 0 in the original equation. If it does, it is not a solution. So what happens, like I said, is when we multiply that LCM, is we actually kind of change the domain to make something that we can solve. So we have to go back and make sure it doesn't make our denominator 0. So to be sure that no computational errors have been made, and that you indeed have a solution, a complete check is necessary. So we're going to kind of do this both ways. Okay. So we have 2 over 3x plus 1 equals 1x minus 6x over 3x plus 1. So we need an LCD. So we see that we can't really do any factoring, but we got these 3 denominators. So we would have a 3x plus 1 and then an x. We multiply those together, that give me an LCD. Because what this makes sure is that this is something that I can divide by 3x plus 1, and I can divide by x. That's what I want to make sure I can do to make it an LCD. Also, like I said, these are the factors of the 2 denominators. There's nothing I can do past this. So we're going to multiply both sides by this 3x plus 1 times x. We're going to multiply that to the 2 over 3x plus 1. And then we're going to multiply it to the other side of my equation as well. And notice I didn't multiply my LCD, and that's just because it makes this next part a little easier for me. We're going to multiply it to the other side of my equation, which is 1 over x, minus 6x over 3x plus 1. So we'd end up with, if I multiply this to the top like I'm supposed to, 2 times 3x plus 1 times x over 3x plus 1. And we see that that's going to cancel itself out. If I distribute this over here, then I'm going to end up with 3x plus 1 over x divided by x. And then we're going to have minus 6x times 3x plus 1 times x over 3x plus 1. And like I said, what should be happening is those denominators get canceled out. So I'm left with 2x is equal to 3x plus 1 minus 6x times x. So I have 2x is equal to 6x squared plus 3x plus 1. So we have a polynomial. So we're going to continue over here. So I really am going to have, like I said, this 2x is equal to 6x squared plus 3x plus 1. I set this equal to 0. So I'm going to subtract both sides by the 2x. Then I have 6x squared plus x plus 1. Okay. So we just need to factor this. So we'll kind of get to the quick part of this for us. So I know that if I do AC method, we're going to have 6 times 1 is going to be 6. So I need multiples of 6 that add up to 1. Oh, this is a negative. There should have been a negative 6 here. There we go. I was going to say something here is not right. That should be negative 6 that add up to this. So we're going to get negative 6x squared plus 3x minus 2x plus 1, because 3 and negative 2 give me negative 6, and they add to give me that plus 1 in the middle. Like I said, I'm just trying to do it a quick version of AC method. If I factor out a negative 3x, then I'm going to have 2x plus 1. And if I factor out a negative here, then I'm just going to have 2x minus 1. If I factor out my 2x minus 1, then I'm going to be left with a negative 3x minus 1 equals 0. So if I go through and solve this, I'm going to get my two solutions are going to be either x is going to be 1/2 or x is going to be negative 1/3. Now what we need to do is I need to check those solutions. Okay. We're going to get rid of what I have over here and just check my solutions and see if they work. Like I said, we're getting things down to, first one was a linear equation. This one was a quadratic we had to solve. So that's the idea of using that LCM, is that we're going to either get a linear or a quadratic. So I want to check my solutions now. So I'm going to check my 1/2 first. So I have 2 over 3 times 1/2 plus 1 is equal to 1 over 1/2 minus 6 times 1/2 over 3 times 1/2 plus 1. Okay. I'm going to do a little cheating and put some of this in my calculator to make this go a little quicker for us. We have 2 over 3 times 1/2 plus 1. This is actually going to be a 0.8. Oops. And then 1 divided by 1/2 is just going to be 2. And then if I have my 6 times 1/2 divided by 3 times 1/2 plus 1, we're going to get a 1.2. And what we're going to see is we're going to 0.8 equals 0.8. So this means that x equals 1/2 is actually one of my solutions. Okay. So now we're going to check the other solution. We're going to check that x equals negative 1/3. So we have 2 over 3 times negative 1/3 plus 1 is equal to 1 over negative 1/3 minus 6 times negative 1/3 divided by 3 times negative 1/3 plus 1. And very quickly, you're going to see there's going to be a problem here. If you do the 3 times negative 1/3 plus 1, I don't know why I put this in the calculator. I already know what this is going to be. This is going to end up being 2 over. So you're going to end up with a negative 1 plus 1. Here, you're just going to end up with a negative 3. And then here, you're just going to end up with a negative 2 over negative 1 plus 1. But what you see here is I'm going to end up with 2 divided by 0, or negative 2 divided by 0. I got negative someplace wrong here. I'm just going to go back and fix it quickly. What's important is I'm dividing by 0, so this is going to be undefined. So because this is undefined, this means that x equaling negative 1/3 is not actually a solution. So this is the thing that happens, is that we get something that's actually one of these places that's undefined. So my actual solution is just going to be the x is 1/2. So like I said, using that LCM or LCD to help us solve these equations, it ends up hiding your domain. So you end up getting solutions that are in the domain of this polynomial over here, but they're not in the domain of the rational function. Okay, so we'll have you try this on 9A, worksheet number 9, A, B, and C. So same thing, you need to figure out what that LCD is, multiply both sides by it, and then check your solutions. All right, so for A, we got 4 over x plus 2 equals 5 over x minus 2. So my LCD, we don't have to do any factoring here. So the two factors I have are x plus 1, x minus, or say x plus 2, x minus 2. So my LCD is going to be x plus 2 times x minus 2. So we just multiply both sides by x plus 2, x minus 2. And as a reminder, we said that this is essentially like being over 1. So you can think about it as being like multiplication, meaning, oops. I hit something on my thing and it started erasing. That means that this and this would cancel out here, and this would be canceling out here. So what I'm going to be left with is just going to be the x minus 2 times the 4 and the x plus 2 times the 5. So we just have 4x minus 8 is equal to 5x plus 10. So if I simplify this, subtract 4x to the other side, we have x plus 10 equals negative 8. Subtract that, we have x is equal to negative 18. So one of the things we could check is, like I said, does this make the denominator 0? So negative 18 plus 2 is definitely not 0. And negative 18 minus 2 is definitely not 0. So this is a solution. So that's one of the ways we said we can check it, is just see, does it make my denominator 0? So x equals negative 18 does not make the denominator 0. Or you can plug it back in and just check it that way as well. And if we did that, we would just see that we have 4 over negative 16 is equal to 5 over negative 20, meaning that we would end up with a negative 1/4 equals to a negative 1/4. So that also tells me that it worked. Okay, so let me do B next. So B, I'm going to start up here with B. We're going to have 8 over x plus 3 minus 6 over x minus 3 equals 2. And if I factor that, that is x plus 3, x minus 3. So in this case, my LCD is just going to be, if I look at each one of my denominators, I have an x plus 3, and I have an x minus 3. So we just multiply everything by that. So x plus 3 times x minus 3. We multiply that to one side, to the 8 over x plus 3 minus 6 x minus 3, which is equal to the x plus 3, x minus 3. And we multiply that to the other side, so that's multiplied to the 2 over x plus 3, x minus 3. So we're going to end up with, if I multiply this here, the x minus 3 and the top and bottom cancel, so I'm just left with 8 times x minus 3. If this distributes over here, the x minus 3 and the x minus 3 cancel, so I'm just left with the 6 and the x plus 3. Here, x plus 3 and the x minus 3 all cancel, so it's just going to be equal to 2. So I have 8x minus 24 minus 6x minus 18 equals 2. So this is just 2x minus, oh, sorry about this. So we have 24 and 18. That's going to be 42. If we add it over here, that's going to be 44. So 2x equals 44. And we're going to have x is going to be equal to 22. Once again, this is going to work. It's not going to make my denominator 0. Once again, if I went through and I checked, we're going to have 8 over, and if we have 22 plus 3, that's going to be 25. And then we have 6 over 22 minus 3, so that's going to be 6 over 19 equals 2 over 22 squared minus 9. Or 75. So 8, if I do this here, 8 plus 25, my calculator, and then I subtract 6 over 19. That would actually be 2 over 245 would be equal to 2 over 245. So I just replaced all my x's that 22. So in that case, it worked. This is a solution. Okay, and then our very last one, let's make ourselves a lot of extra room for this one because it's going to take quite a bit more space. So I'm going to get rid of all of this right here, all of this right here. So if I write C and expand it, or not expand it, do any kind of factoring I need to do, that's going to be A over A minus 2 plus 1 over A minus 6 equals 4 over, if I factor that, that is going to be A minus 6, A minus 2. So the LCD is going to be A minus 6, A minus 2. Because like I said, these are all my different factors. So each denominator, one factor is an A minus 2, one's A minus 6, and this one's A minus 6, A minus 2. So we just have an A minus 6 and an A minus 2. So I multiply both sides by that. A minus 6, A minus 2, over 4, A minus 6, A minus 2. Okay, so like I said, if this distributes here like before, the A minus 2 is canceled, so we're just going to have A minus 6 times A. It distributes here, the A minus 6 is canceled, so you're just going to be left with the 1, A minus 2. Here, the A minus 2 and the A minus 6 cancel, and you're just left with the 4 on top. So I'm going to have A squared minus 6A plus A minus 2 equals 4. Or we have A squared minus 5A minus 6 equals 0. Okay. So we can keep this going. We're going to get rid of our original version of the question right here. All right, if we factor that, that is going to be a, we see, I think it's going to be minus 2A minus 3 equals 0. So my solutions are either A is 2 or A is 3. So if we go back here to my original equation, what we see here is that if A is 2, I'm going to have a denominator of 0. If A is 3, then I do not. So the only one that's actually going to be a solution is going to be that 3. So like I said, you can check that way, or we could just do it the hard way. Not the hard way, but the long way. We can actually just check our solutions. So usually if you end up with 2 solutions, you're probably going to have to definitely check them. But well, let's say in all cases, you definitely want to check them. But one of the things you want to make sure is they do not make your denominator 0. So let's check A is 2 or A is 3. If A is 2, then we have 2 over 2 minus 2 plus 1 over 2 minus 6 is equal to 4 over 2 minus 6, 2 minus 2, which is going to be 2 divided by 0 plus 1 over minus 4 and 4 divided by 0. Undefined, this can't be a solution. If we do the 3, then we have 3 over 3 minus 2 is just 1, plus 1 over, if I have 3 minus 6, that's going to be negative 3. I just don't have room to do it otherwise. And then 4 is just going to be 3 minus 6 is negative 3 times 3 minus 2 will just be 1. So I end up with 3 minus 1/3 equals minus 4 over 3. Just checking my answers here. 3, 3, 3. Yeah, we're okay. Just checking it. So I made a mistake. And it was a silly one too. I think we get a little tired here. So it's A minus 6, A plus 1 is the factorization. So my solutions, and that is why it pays to check your solutions. Because I was checking it and I realized I had one wrong. So this is 6 and minus 1. So now if we go back and we check again, now if we use 6, we're going to have 6 over 6 minus 2 would be 4, plus 1 over 6 minus 6 would be 0. So if I do that one, we get, like I said, 6 over 4, 1 over 0, and then we would have 4, and we would have 0 times 4. It'll be undefined because we'll have 1 over 0. So this is not a solution. Now, if we check that negative 1 now, then we're going to have a negative 1 over negative 1 minus 2. That will be negative 3. Plus 1 over, if I have negative 1 minus 6, that's going to be negative 7. And that is going to be 4 over negative 7 times negative 3. So we're going to have 1/3 minus 1/7 is equal to 4 over negative 21. Okay, so here, this would be 7 over 21 minus 3 over 21 equals 4 over minus 21. Oh, sorry, that'd be plus 21. Dang, tools. And then we would end up with the correct answer, which should be 4 over 21 equals 4 over 21. So this would be my only solution. Like I said, so like we did before, as you saw, I checked with when I thought my answers were 2 and 3, and it looked like one of them was going to work for me. But then when I started checking it, I started realizing partway through that it wasn't matching up. That's always your hint. Like it's always a reason it's a good idea to check your answers. So using your domain or figuring out what's going to make your denominator 0 is good in a way, and like you can quickly eliminate an answer. Except if you made a mistake like we did, or I did, factored it incorrectly, then it gives you the wrong answers. So it's a mistake, but it's a mistake it pays because it teaches us a lesson right here that it does work to do your checking here. So don't always go, well, which one's undefined? That's the one I throw out. You still want to check them both to make sure your answers do work.